Guys, let's do number 1. A particle P starts from point O, that's the origin, and moves along a straight line. The graph of its velocity after t seconds between 0 and 6 is shown in the following diagram. All right, so this is v of t. The graph of v has t-intercepts when t equals 0, 2, and 4. So t-intercepts in the velocity function are going to be when the velocity is equal to 0, right? It's when it's crossing the t-axis. So we would have v of 0 is equal to 0, v of 2 is equal to 0, and v of 4 is equal to 0. I'm just like kind of translating these little bullet points into math in case we need to use these pieces of information later. The function s of t represents the displacement of p from the origin after t seconds. The way we would generate s of t is by integrating the velocity function with respect to time. That would give us, that would give us s of t, which is the displacement function. It is known that p travels a distance of 15 meters in the first 2 seconds. So total distance traveled is going to be area under the curve. So between 0 and 2, we've got an area of 15. It's also known that s of 2 is equal to s of 5. Okay, so the displacement from the origin when s is equal to 2 is the same as when t is equal to 5, sorry. And then also between 2 and 4, the velocity, or the the integral of the velocity function is going to be equal to 9. So the area under the curve between 2 and 4 is going to be 9, aka the total distance traveled between 2 and 4 is going to be equal to 9. So what we want to do here is find the value of s of 4 minus s of 2. Okay, so if we are given that the integral of the velocity function is equal to s of t, we should know that if we put in bounds of 4 and 2, when we integrate this velocity function, we should get s of 4 minus s of 2. So we've kind of like generated this from the given information, okay? And we do know right up top, it tells us that this guy is equal to 9. So s of 4 minus s of 2 must equal to 9 because it was pretty much just given to us. So we have our first answer as 9. 1b, find the total distance traveled in the first 5 seconds. Total distance traveled, we're going to be doing this plus this piece plus this piece. Notice that this guy's area is below the x-axis and that these areas are above the x-axis. So they're going to be positive. Okay. So we are going to try to find the total distance traveled, which would be the integral with respect to time of the velocity function between 0 and 5. However, we're not doing absolute value by hand. We're just splitting it up at the intercepts and adding them together. And then, of course, regions located below the x-axis will be subtracted to account for the fact that they are currently negative areas and we need them to be positive. Okay, so the integral of velocity from 0 to 2 is 15. They already gave that to us up here, right? The area under the curve from 0 to 2 is 15. And then they give us 2 to 4 as well. They give it to us as 9. So we're going to go ahead and put this guy as 9. So I've got 15 plus 9 minus, and then what is this guy? We do not know. Let's figure it out. Okay, so down here, what I'm trying to figure out right now is if I integrated the velocity function between 4 and 5. So I know that the antiderivative of the velocity function is going to be the position function. And then I know that I'm going to be evaluating s of t at 5 and then subtracting s of 4. Okay, so this would be s of 5 minus s of 4. S of 5. Let's think about it. Where have we seen S of 5 before? Oh, yes. In the beginning, they told us that. Hold on, I'm going to use different. In the beginning, they told us that S of 5 is equal to S of 2. So let's use that information, right? We have S of 2 is equal to 15, right? They told us that the displacement from the origin after 2 seconds is 15 meters, right? So we know that S of 2 is 15. S of 5 must therefore be the same. It must be 15 as well. However, it's negative because it's below the x-axis, right? S of 5 would have to be negative 15. So this guy is going to be negative 15 minus, let's talk about S of 4. How do we find S of 4? S of 4. Well, where did we see an S of 4 before in the problem? Let's look. Right here we have S of 4 minus S of 2 equals 9. So we've got S of 4 minus S of 2 equals 9. Let's try to solve for S of 4. And we would get S of 4 is equal to 9 plus S of 2. And then the problem tells us that S of 2 is equal to S of 5. That was given. So now I just have S of 4 is equal to 9 plus S of 5. And S of 5 is the same thing as S of 2, which is going to be 15. So I've got S of 4 is equal to 9 minus 15. Okay. So now I've got 9 minus 15, which is going to give me S of 4 equals negative 6. So I've got negative 15 minus negative 6. Careful with the signs there, but that would just give me a negative 9. So the final region that we were looking for is going to be negative 9. So I would add those together. I would get 15 plus 9 plus another 9, and that would give us, ooh, don't get frozen, come on, a total distance traveled of 30